This is the largest type of plantation in Indonesia. Everyone surely recognizes this plant. It is a commodity that significantly contributes to Indonesia's exports, second only to oil and gas. In 2015, the export value of products from this plant reached $18.1 billion, contributing 13.7% to Indonesia's total exports. Indonesia dominates the global palm oil industry, boasting the largest plantations and the highest production capacity in the world. In 2016, the total production reached 35 million tons. These oil palm plantations are spread across 22 provinces. The largest areas are in Rio, East Kalimantan, Central Kalimantan, and West Kalimantan. However, the majority of plantation landowners, especially in Rio province, do not manage their own plantations. They entrust the management of the plantations to others, thus not being directly involved in the supervision and fertilization of the land. The manual fertilization method that is still used today has become less efficient, especially on very large areas. In addition, pests and diseases are significant problems that can reduce the productivity of oil palms. One method for controlling pests and diseases is by applying fertilizer on the soil surface top dressing. However, this method still has limitations in terms of efficiency and supervision. Therefore, we from Polytechnic Koltex Rio, with Zaid and Rafif Pratama, Rahadatalezi, Kenji Madi, and Sinsha Widiasari, we have designed an innovative system that simplifies the process of automatic and efficient fertilization of oil palm trees, namely, the Smart Fertilization for Palm Oil Trees, an IoT-based automation solution. This system is designed using pushcart with 20 kg capacity for fertilizer, disconnected to a servo motor. 20 kg load cell measures fertilizer mass. HX711 module converts analog to digital signal. Data displayed on an LCD and monitored via smartphone app, controlled by ESP32 microcontroller, which also operates the servo motor. RFID technology identifies fertilized trees, reducing fraud. With this system, significant benefits will be achieved, namely, first, increased efficiency. The automated system speeds up fertilization, making it quicker and more accurate than manual methods. Second, better supervision. Real-time monitoring via smartphone ensures the correct amount of fertilizer is applied to each tree. Third, improved production. Accurate fertilization leads to healthier, more productive oil palm trees, enhancing both quality and quantity. 4. Fraud prevention. RFID technology ensures proper fertilization and reduces the risk of worker fraud. And last, sustainable agriculture. IoT technology promotes modern, sustainable farming practices, supporting Indonesia's palm oil industry. The process starts by placing the fertilizer, and the load cell detects the weight. The HX711 converts the data to digital, which is sent to the ESP32. If the data is correct, it is saved temporarily. The data is displayed on the LCD, and if needed, it can be sent to the app by pressing the send button. Pressing the start button begins fertilization. After completing fertilization for a row of trees, the RFID tag is scanned to confirm the process. If more fertilizer is needed, the add button is pressed, and the process continues. This system is programmed using Arduino IDE, with the ESP32 as the main controller. The load cell detects weight and is connected to the HX711 module, which converts the data into digital format for the ESP32 to process. Here is the display on the smartphone application. The smartphone app shows the temporary and total weight on the main screen. In the View menu, it displays which rows of trees have been fertilized. The app is developed using Android Studio. This test evaluates the accuracy of mass readings using a load cell sensor for weighing oil palm fertilizer. Conducted 20 times with varying loads, the results showed an average difference of 0.21 kg and 98.17% accuracy, confirming the sensor's reliability. For the fertilizer spread test, with 10 trials, the average spread distance was 31.4 centimeters, and the average time to fertilize one tree was 47.5 seconds, showing efficiency and variability based on conditions. The RFID MFRC522 test, conducted 14 times over 2 weeks, confirmed its accuracy in detecting fertilizer amounts 1.03 kg to 18.02 kilograms and flexibility across different times of the day. The Android app test confirmed that the app successfully receives and displays load cell data, enabling the tool to transmit weight readings to the application via Firebase. From the tests that have been conducted, the following can be concluded. First, fertilizer dispensing accuracy. Second, fertilizer spread efficiency. And third, monitoring and control capability. The automated oil palm fertilization tool performs well in fertilizer accuracy, distribution efficiency, and IoT-based monitoring and control. The integration of load cell and RFID technology improves the fertilization process, providing an effective solution for landowners to optimize and manage fertilization more efficiently. The conclusions of this project are: first, the load cell sensor accurately measures fertilizer weights up to 20 kilograms. Second, the average accuracy of the load cell sensor is 98.17% across 20 tests with varying loads. Third, the average fertilizer spread distance is 31.4 centimeters, and the time to fertilize one tree is 47.5 seconds. And last, the RFID MFRC522 accurately detects and transmits fertilizer data, with varying amounts used in each test. This is the demonstration of our tool. Turn on the system. Place the fertilizer. Press the Save button to store the fertilizer weight reading. Press the Send button to send the fertilizer weight reading to the application. Temporary data will be stored in the temporary weight. Press the Start button to activate the fertilizer servo and open the valve servo. Press the Start button again to turn off the fertilizer servo and close the valve servo. Press the Add button if you want to add fertilizer, and repeat the previous steps. Attach the RFID tag to end the fertilization, and update the data for the rows of trees that have been fertilized. The fertilizer data will also automatically be added to the total weight. That's all from us. Thank you for your attention.